In the center, we have the protons and the neutrons. The protons are positive, the neutrons are neutral. They determine the type of atom and the mass of the atom. And then we said, or we started to say that the electrons you will find in the orbitals around the nuclei. Their mass is neglectable. What in the world does neglectable mean, Bontle? It is neglectable. Yes, it's as if you don't have to consider it. It's so small that we don't even look at it. Okay? So neglectable. So it does have a mass. It's not zero. It does have a mass, but it's so small we do not consider it. And then the charge is -1 because an electron is negative. And an electron determines the volume and the chemical reactivity. And I explained the volume for you, and Simpiwe helped me to explain that. Can you remember what I said regarding the volume and the electrons? She put up a pencil. Why? What did I say? I said something, if you take away all the electrons, what will happen? It will shrink. The mass will stay the same, but the volume changes. So we see that the protons determine the mass, the electrons determine the volume, the size that it is. All right, if we look at the helium atom, Karabu, how many protons does helium have? Yeah, Bondle? 2, because its atomic number is 2. So it has 2 protons. The protons you find in the nucleus. Alright, how many electrons will a neutral helium have? The same as the number of protons. So the electrons we find in the orbitals, and you can see I draw them as far away from each other as possible because negative and negative repel. Okay, now Fatima. What is the mass of a helium atom? Okay, this is where you all see I'm referring to the periodic table the whole time. Maybe take out your periodic table because you will need it. What is the mass? Xavier? 1 for helium. Are you at helium? Helium is on the right hand side. 8. Helium. 80. Helium. No, it's in group number 18, but it doesn't have a mass of 18. Four. So the mass, the mass is 4. Okay. Now we said the mass consists of what and what, Dimokatso? Now look, what takes up or makes up the mass? Alright, yes, Timakaso, what makes up the mass? No. Volume makes up the mass. No, 2 different things. What determines the mass? Say again? No. Look here at the top. Shh. The protons and the neutrons together give you the mass. So we can say there, wait, I'm going to say it at the bottom here. So the mass, is mass with two M's? Mass is the number of protons plus the number of neutrons. Okay. Now for helium, the mass we said was 4. We found that on the periodic table. The number of protons we figured out was 2. So how many neutrons will the helium atom have? You can see when you take it to the other side, it subtracts. You get 4, negative 2 gives you, you can just put it down, thank you, 2. So this means that there's 2 neutrons. Okay, so I draw 2 neutrons in here. Okay, so what you must get from that is, nowhere on the periodic table, you will find the number for the number of neutrons. You have to go calculate it. How do you calculate the number of neutrons? You say it's the mass minus the number of protons. Write that down somewhere, that's important. To determine the number of neutrons, it's the mass minus the number of protons. Now I see some of you did struggle to locate the mass on the periodic table. If you look on your periodic table, in the middle there's a key. At the key it shows you copper, shows you at the top, the atomic number is 29, that determines the number of protons. At the bottom you see the approximate relative atomic mass. At the bottom you get the mass, and then on the left hand side there's something called the electronegativity. Don't worry about the electronegativity just yet. We'll discuss that in the next chapter. Okay, so for now, the atomic number, number of protons, and the mass you must be able to do. Alright. Here on the right hand side of this page, it just says the electrons flow in a wave pattern in the orbital, so it just means the electrons move like this in a wave around the nuclei. And then in the nucleus, or the nucleons, what do they exist of? The protons and the neutrons. And we found them in the nucleus.
No?
Yes. If I can lock you in there.
No, if you can lock the class.
Or did you not lock the class? Well, I'll lock the class. Alright. Okay. On the next page, we have a symbol to represent an element. Okay, so an element, like on your periodic table, we represent by an E, so E stands for element, and then we have an A and a Z, so we summarize it. Instead of saying a lot of words, we can summarize an element into a symbol. Okay, now that E stands for the element. The Z there at the bottom, the Z is the atomic number. Atomic number. Okay, now if something is in a block, it's a definition that you need to know. Atomic number gives you the number of protons. We said that already, a number of protons of each atom of the element and the position on the periodic table. Okay, so if I say element number 30. You know, okay, I have to follow where's 30, there's 30. Okay, so you follow with the number line. Ne? Right, that is what the Z stands for. Then we're going to look at the atomic mass, or A. A represents atomic mass. That is the total number of protons plus neutrons. We said that on the previous page. The mass is the total number of protons plus neutrons. Okay, So if we look at gold that was given here, if I have to write it in this form, rewrite it in this form, then I'm going to say, okay, we have gold, AU. Then the number at the top, A, there, is the mass number. Okay, simply way, what is the mass of gold? Look on here. Okay, if you look on your product table, it will be 197 because it's rounded up. Okay, so you're going to use 197. So there at the top, we write 197. Because A represents the mass, you write that at the top. Then the Z represents the atomic number. Enough. What is the atomic number of gold? 79, you write here at the bottom. So this is the symbol to represent gold. Now, when you go to other textbooks or past papers or extra classes somewhere else, they can write it on the right hand side as well. So it can either be written on the left or on the right. It doesn't matter. Okay. Right. So let's see if we can use that symbol to do the following. So we have to, for each of the following, give the symbol, the protons, neutrons, the nucleus charge, positive, negative, what, and the number of electrons. Oh, sorry, I just want to say, hashtag, the original meaning of hashtag was actually number of. Hashtag is not just for hashtag whatever. Okay, hashtag actually stands for number of, number. Okay, so how do you read this? Number of protons, number of neutrons. Okay, wait a minute, what is helium symbol? He. At the top, Relo, A, is that the mass or the atomic number? Say again? This A here, is that the mass or the atomic number? And what is the mass of helium? No. 4. So the bottom one is the atomic number, and that is, Tego. Say again? The atomic number of helium? 2. Okay. So from there we can derive. Junior, what is it? Junior, Ria, what does the word derive mean? I say from that we can derive. It's not on here. I'm asking you an English word. What does the word derive mean? Anyone? You can conclude, you can say, you can give a explanation, or you can give a reason, or you can make an assumption. So from here we can assume the following. How many protons does it have? 2. Why? Because the atomic number is 2. How many neutrons will it have, Junior? How do we calculate the number of neutrons again? Shh, Junior. How do you calculate the number of neutrons? Yo, do I really speak so softly that you can't hear me at the back? To me, I'm screaming. We wrote it down on the previous page. How do you calculate the number of neutrons? Say again? Yes. Okay, so the number of neutrons, how do we determine it or calculate it? We say it is the mass minus the number of protons. Okay, Bontle, with that information, how many neutrons does helium have?
2.
How did you get to 2?
This number minus atomic.
Yes, you said 4 minus 2. You don't have to show that in a test. This is just for completion's sake. Then, Karabu, what is the nucleus charge? Okay, now charge refers to, is it positive or is it negative? And then how much? Positive or negative? Yes, and how much? 1, 2, 3, 4, 5, 6, how much? In helium's nucleus, what do you find there? The protons and the neutrons. Does the neutrons have a charge? No, they have no charge. How many protons are there? So don't overthink it. And then refill away, how many electrons will it have? Why do you say 2? It's the same as the number of protons in a neutral atom. Okay, next one. Fatima, sodium's symbol. Na. Dimakatso, what do we write here at the top? The mass or the atomic number? Yeah, the mass. And what's the mass of sodium? 23. What's the atomic number, Bukamuso? 11. Right. So how many protons does it have, Simpiwe? Shibbit. One of the two things here indicate the number of protons. "11." The same as the atomic number. Good morning. Are you awake? Enough. How many neutrons are there?
12.
How did you get to 12? Yes, the mass minus the atomic number or the number of protons. What will be the nucleus charge? What you may look. Don't do any calculations. You must just see it. It's there already. What is the nucleus charge? The charge will be the same as what? No. The neutrons, that's 12. Does it have any charge? No. So the neutrons does not determine the charge. In the nucleus, what do we find? We find the neutrons and we find the protons. Oh. So what will the charge be? Alright, and then it has 11 electrons because it's the same as the number of protons. Relo, uranium's symbol. A U. Tejo, what do we write at the top? The mass or the atomic number? And what is the mass of uranium? Uranium is way at the bottom. Way at the bottom. Number 92. 238. And I just said the atomic number is 92. So Ria, how many protons will it have? You can only call some Pee-wee. That's the only person you can call. 92. It's the same as the atomic number. Junior, how did we get to 146 neutrons? Yes, you said 238 minus 92. That's how we got that. Then what will be the nucleus charge, Puntle? Puntle? Yes. And how many electrons, Karabu? 92. Alright. To practice this, because it's something you need to know, please go to page 12. So on page 12, you can see there is a table, a lot like we did now, except I don't ask the nucleus charge. Okay, so you're going to fill it in. I quickly want to do two ones, because I did ask it a bit more complex here. Okay, so I quickly want to do the magnesium ion, and I want to do this one that doesn't have a name. Okay, so the rest you're going to fill in as homework. We're going to start with the magnesium ion. Way. What is magnesium's valency symbol? Say again? Magnesium. Not manganese. Mg. Mg. Alright, Fatima. What is its mass? 24. And its atomic number? Dimakacho? 12. Alright. Now they do tell us there that is magnesium ion. I told you we get a cation and an anion. They're two different things. Ion means it lost or it gained, gained electrons. It lost or it gained electrons. That is what an ion is. It's a plus or a minus. Can it lose or gain a proton? No. If it loses or gains the protons, it's an atomic bomb. It can never lose or gain protons. It can only lose or gain electrons. Okay. There was something else I wanted to say there. I can't remember. Yes. Magnesium. On the periodic table, in which group will you find it? Group what? Say again? Group 2, and the name of group 2? Alkali? Alkali earth metals. Simply way, what do group 2, the valency of group 2 elements become? Positive 2. Enough, does that mean that it lost or it gained electrons? It lost 2 electrons, but man, it's 2 plus. Electrons are negative. So if it loses electrons, then it has more protons. So it lost 2 electrons. Okay. So that's a notation. So it gets more complex. Okay. Boitomelu, how many protons does magnesium have? 12. Can that change? No. It can't become 14. Then it's not magnesium anymore. Then we sit with silicon. How many neutrons, Relo? How did you get to 12? Yes. And now the difficult one for you, Tseho. How many electrons does it have? Put down your hand. How many did it have to start with? it had 12, the same as the number of protons, right? But now it says 2 plus. The 2 plus doesn't mean it lost or it gained electrons. It lost. So it had 12 electrons, it lost 2 electrons. How many does it have now? 10. So that's 12 minus 2 gives you 10. Okay, so you can see what I mean with it becomes more difficult. Okay, let's quickly go to this one here. Okay, I only give you the number of protons and the number of electrons. You always start with the number of protons because that can never ever change. Okay, so that's always your constant. Bontle, what are you busy with? What's in your hands? The other hand. Alright, so what area, does have 20 protons? Near, left. Say again. What is CA's name? Calcium. Okay, so we have there calcium. I don't know if it's calcium ion or not, so I'm just going to write calcium for now. I know I'm not finished with that. And the symbol for that is Ca. Right. We already determined the number of protons. It's the same thing as the atomic number, which I write there at the bottom, 20. Junior, what is the atomic mass of calcium? Say again. 8. The mass. No. I can't hear. 40. 40. Alright, Bontley, how many neutrons does calcium have?
8.
How did you get to 20?
14 minus 2.
Yes. Now they tell you that it has 18 electrons, but it has 20 protons. So there's a difference. Did it lose or gain, Karabu? This differs from this. Did it lose or gain? And how do you show that it lost? You write 2 plus. So that will be calcium ion. If this was also 20, then it would have just been calcium. Okay, are you with me? So this is your homework to complete this table. Okay, wait, you're not going to start with it now. You have to go on with the lesson. We have another 20 minutes. I know, time flies when you're having fun. Alright. Now, we're going to go to isotopes. Isotopes. Okay, now, I lied to you before. I told you that all atoms of the same element look the same. I told you, if you find lithium, then lithium will always look that way, but I lied. Okay? In nature, we find something like a twin or a triplet of atoms. Okay, you know what twins are? Next. Is there a twin in grade 10? In grade 12? Who's in grade 12? Keegan and... God, I don't know what's the other one's name. Keegan and someone. In grade 8, there's a lot of twins. I think in grade 8 there's 4 twins. There's 3 white boys and 1 black girl twin. They're quite tall. I don't know their names, I just saw them. Alright. So you've all seen twins before, right? And when you see them originally, you're like, how the hell does anyone know who's who? Yes. When you see them, you're like, what in the world? And then when you get to know them, you spend time with them and you become close with them, you realize, yo, they're so different. They're actually like, how do you not see a difference? Have you Have you been friends with twins? Yes, they're not aliens then. Be nice to them. Right, so when you get to know them, you know there is quite a big difference. Now the same thing with certain elements on the periodic table. When we find them in nature, we actually find them as twins or as triplets. Not the fact that they are together the whole time, not the diatomic molecules. We just find, let's say we have carbon, then we have a carbon and another one, and they're all carbon, but there's something that is different between them. And those triplets or twins we call isotopes. Iso means the same but different. Okay, so iso means same but different. Okay, so isotopes. Let's read what is the definition for an isotope. It says there, isotopes are atoms of the same element. Now when we say the same element, that means the number of protons must be the same. The number of protons must be the same. Okay, so the same element, but with different number of neutrons. So the neutrons do differ. Not the electrons, not the protons, the neutrons. And because the neutrons differ, their mass also differ. Okay, because we know the neutrons determine the mass. Okay, then just for interest's sake, not something that you need to know, but isotopes with a higher mass, so the heavier it becomes more radioactive. Radioactive, I told you, we use in when someone has cancer with radiation, right? And then it splits up basically, or it bombs your cells. So it becomes radioactive, and it plays an important role in radioactivity and medicine. Right, now we're going to look at 3 of these isotopes. We're going to look at hydrogen, carbon, and chlorine. There's more, but for now in this class we're going to look at 1. Now hydrogen is actually a triplet in nature. So there's 3 isotopes. Okay, they have names. Then the first one's name is hydrogen, then deuterium, then tritium is their names. You don't have to know their names. Okay, you just need to know, or you must be able from here derive, conclude, get information. Okay, so you don't need to know the 3, you just need to be able to work with them. Okay, so the first one there is 1,1, as you can see. So where are we with our questions? No, Karabu did. Yeah, refill way. For the first one, how many protons does it have? 1. And how many neutrons, Fatima? Think. No. How do we calculate the number of neutrons again? It's the mass. Okay. Look here. The mass minus the protons. 0. So it has no neutrons. And that makes hydrogen very special. And we're going to work with that a lot in grade 11. Alright. The second one, so how many protons? And how many neutrons? 1. And Simpiwe, the third one, how many protons?
1.
And Anaf, how many neutrons? 2. So can you see that the protons remains the same? Always. It can never, ever, ever, ever change. It's the number of neutrons that change. Botemilo, for a bonus question, which one between the 3 isotopes will be most likely be radioactive? Tejo? Say again? No? Enough? Why? Because it has more neutrons. It has a higher mass. I just explained it. And when I said no, you don't have to know this for exam, you switched off. You must still listen. Maybe I will put it in the exam. Yeah. Nee? Alright, next one. Carbon is also a triplet in nature, meaning it has 3 isotopes. Now the names here are much simpler. Here they say the name will be actually with a line in carbon 12, carbon 13, carbon 14. That is the name. Carbon 12, why? Because the mass is 12. Carbon 13, because the mass is carbon 14. So the names are quite easy. Okay. What is carbon 12's number of protons? 6. Relo, number of neutrons? How did you get to 6? Alright. Tsecho, carbon 13, how many protons? And neutrons, Ria? Yes. And Junior, how many protons for carbon 14? And Buntle, how many neutrons? Alright, and then the last one is the chlorine isotope. It has 2 isotopes. It's a twin in nature. Karabo, how many protons? 17. Rafilwe, how many neutrons? 18. Fatima, next one, how many? And Yokatso, neutrons? 20. Alright, easy peasy. Let's make it more difficult. Okay, right. Now, I already said something that should have made you wonder in class today. When we looked at, I think it was gold here at the top. The mass there was 196,967, and on yours it is 197. Okay? If you check on my periodic table here in front, you can see the mass every time it's not rounded off. Like if we look at oxygen, it's 50.9994, whereas on your periodic table it is 60. Okay? Now yours is rounded up or rounded down because to make it easier for you, but mine is more correct. Okay? Now how can we get a comma, comma, comma? If we look at like chlorine for instance, chlorine is 35 round off, like on yours is 35.5. We said the mass is the number of protons and the number of neutrons. Can you get a half proton or a half neutron? No. So where do we find these commas? It should be all whole numbers. Why do we have commas? It is because in nature, it's because on here we took the relative atomic mass, meaning the average of all the masses together. Okay? Let's say your whole class is one element. Let's say you are all, I think you're 14 or 11 in this class. 5, 10, 13, yeah, well, that's 14 in this class. Let's say you are all, what is like a 2 over 14? Someone that has 14 babies of the same that was born on the same day. But you all get what I'm saying. So you're all born on the same day, you're the same sex, you're the same everything. Okay? But you're all a bit different. And you've never seen people 14 of the same baby that looks the same, weighs the same, blah, blah, blah. Okay. So let's say you are all the same element, the same baby, but your mass is all slightly different. Okay, let's make up an element. Let's say your element, what? Element cool. Element what? What do you want your element's name to be? What? No, but that already exists.
I said veritasium.
A veritasium.
Yeah.
Okay, alright. If you are veritasium, that's your element. Okay, and I must now, for the veritasium, so what is your veritasium?
V-E-R-I.
Yeah, but your symbol. Veritasium, that's what you are. And your atomic number is, let's say it is 500. Okay? And I want to know what is your mass. I want to write it down there. But your mass is all different. right? You not want the same mass. So what we write down there is the average mass. So the reason why it has commas and everything there is because it is an average mass of all the twins or triplets or whatever you find of an element. Are you with me? Okay, so this here that we find there, this X there, is the average mass. We call it the relative atomic mass. The relative atomic mass. Pontley, I'm going to take that thing and I'm going to throw it out the window. Relative atomic mass. Okay, so let's read and then I'll explain again. The symbol for relative atomic mass is an AR, like argon, but it's not argon. They say most elements occur as one or more isotopes in nature. So almost every one of the elements on the periodic table is a twin or a triplet or a quadruplet or whatever. Because the mass of a proton is so small, scientists prefer to express its mass as in one atomic unit. Sorry. Okay, so I just told you on the first page we said the mass of a proton is 1 unit. That's what we wrote it down on the first page. Okay. Now, the definition for a relative atomic mass is the following. The relative atomic mass of an element is the average mass, I just told you it's the average mass of all its isotopes. The average mass of all the isotopes together. And now it gets complicated. Relative to the mass of the carbon-12 isotope, we just looked at the carbon-12 isotope, which has a mass of 12 atomic mass units. Ma'am, what did you just say? Okay. Ja. Nee, ek het hom ingestuur vanoggend. Alright. What did I say? What? The carbon proton. Now, the mass of a proton is super. Okay, so we can't put it on a scale. You will never be able to weigh it on a scale. Okay? Now, I told you at the beginning when we looked at the periodic table, I told you silicon and carbon are very special elements. Remember I said that? Okay, what I'm saying is now they're very special. And the reason why we look at carbon is one of the first elements they discovered. Okay, they say, oh, this is carbon, it looks the same. We use it quite a lot in everything. So your table, your pencil case, your highlighter, your clothing, your hair, your food, your everything has carbon in it in a different form. So carbon is quite, you find it a lot, we use it a lot, and they discovered it first. Okay, so they could have done a lot of experiments on the carbon. So they determined the mass of carbon first. Okay, and carbon is relatively heavy, so they could have measured it, whereas hydrogen is not heavy at all, so it's very difficult to measure. And they use carbon-12 because they also use it for carbon dating. Have you heard about carbon dating? Where they use it to determine the age of fossils and so forth and so on, carbon dating. So they measure the mass of carbon as on how fast it deteriorates. Okay, so they said, let us refer all the masses back to carbon. We make everything relative to carbon. Okay? It's like, let's say in this class, the fuel is the I think of the soup not the sweetest, not the most well behaved, and she's the cleverest, and she's just the perfect student. Okay? Then someone will ask me, oh, what do you think of Fatima? And I'll refer her to the fuel. I'll think, okay, the fuel is 100 out of 100, then Fatima is like a 7. And then I'll say, oh, Fatima, she's alright, she's not that, but she's alright. You know, we all have something that we compare something else to. Okay? If you say, your science is so difficult, then it was, what do you compare it to? Do you compare it to math lit? Do you compare it to business? Do you compare it to mathematics? Do you compare it to accounting? Then we would also say different things. Compared to mathematics, yes, it's difficult. Compared to accounting, yeah, it's not that difficult. Then, are you with me? Right. So what we did, or what they did here, is they said, right, we're going to get the mass of an atom compared to, relative to, compared to. So if you don't know what relative is, you say compare. Compared to the mass of a carbon-12 isotope. So we compare everything to carbon-12. And carbon-12 has 12 mass units. Okay, so that's just a definition. It's a very complicated definition, but they do like to ask it in a test and exam, especially in grade 10. Okay, then at the bottom they say there, as the relative atomic mass of an element is the average mass of different isotopes. It is seldom a whole number, meaning it's never a whole number. Seldom is almost never. Okay, then AR stands for the relative atomic mass of an element, appears below its symbol on the periodic table. Okay. Now, I know it's on your periodic table, but they expect you to be able to calculate the mass of each element on the periodic table. That's an isotope. So that's what we're going to practice doing here today. Okay? So it says there, calculate the relative atomic mass, AR, of chlorine that exists as 75.5% chlorine 35. So the chlorine 35 isotope, you find 75.5% of the time. And chlorine 37 isotope, you find 24.5% of the time. And now you must find the relative atomic mass. Okay, so what you're going to do is you're going to write the two isotopes below each other. Those are the two isotopes that we have. Okay, then you're going to write the 35, so the mass is 35. How frequently or what percentage do you find it in? You find it as 75.5%. You can see I don't write the percent at all, the percentage. And the other one, the 37, we find 24.5%. Can you see if you add these two together, you find 100. Okay, I'm going to stop there. You know what your homework is? That table. All right.